Hello friends, so this is another round of our reviews. Today we only have 1 hour though, because we have another meeting in the second hour that I have to go to. And since I'm streaming, the meeting will go with me, unfortunately. So, this one we have punted now 4 times in a row, I think, so it's time that we bring it to the front of the queue and we talk about it. Unfortunately, Eric isn't here, but Steven is here, so maybe Steven can talk to it, otherwise I can talk to it too. Steven?
We can split the duties. Basically, the question is, we have been somewhat inconsistent as to whether we ship all the attributes that the C# compiler relies on. In many situations, the compiler will inject attributes into the assemblies it's building. In some cases, we have centralized that by shipping those same attributes publicly in the core libraries, and then Roslyn will see that they exist and won't emit them. But in other cases, we haven't. And so the question is, should we try to more consistently put as public in core lib the various attributes that that Roslyn might inject into assemblies? For example, the ones on the screen for nullable, these are not the attributes that the developer uses, not null when or allow null or so on. These are the ones that describe in metadata with how various parameters are or are not attributed or annotated rather with question marks and the like, and optimizations for how that is represented. So that's the nullable attribute there, nullable context attribute. And today, Roslyn just emits those into the assembly. The question is, should we instead be shipping them publicly so that we avoid that bloat in each assembly? There are various questions around this. Does it in any way slow down our ability to innovate in the compiler? Does it end up baking in too much implementation detail into public API? If we're doing it for C#, should we be doing it for F# as well, or any other languages? How come we've done it for some attributes and not for others? Like we just did it for the new ref safety attribute, which again isn't meant to be consumed by developers. That's just something that Roslyn was baking into every module, and so on and so on.
Yeah, I wanted to provide another bit of context behind where the split is today, which is some older attributes like extension attribute and such. Back when we only had .NET Framework, we weren't shipping across all these sorts of different targets. Those attributes ended up in the BCL, and after, I don't remember exactly when, but at some point when we started shipping across all these different targets, we needed to add more of these attributes, and we talked with runtime folks, with you all, and we said, hey, where should we put these things? And what we came up with is a split of basically the attributes that users use go in the BCL. So for example, not null when, don't return or does not return, all those things that users are actually expected to apply themselves go in the BCL. And when people try and down target things, they have to polyfill them themselves. For everything else, Emo, can you bring back the...
Yeah, sorry.
Thank you. For everything else, all of these attributes that users are never using these things. They're not putting is unmanaged on things. They're calling something a ref struct. They're not putting nullable attribute on things. They're putting a question mark. For these things, the compiler generates the attribute definition. And that's the split that was decided on when we started needing to figure out what do we do across all these different target frameworks, where we're not going to get the attribute definitions to everything. In terms of actually putting these things in the BCL. I don't think we have a problem with it. The main thing that we need to be concerned about is where an attribute is actually consumed from. For example, let's say we have, if we need to make sure that we're very careful about depending on a type from an assembly and then saying, okay, that type is now gone, and the user never knew about this type, right? They didn't generate is unmanaged. They didn't put is unmanaged attribute in the assembly themselves. The compiler did. If that assembly is recompiled on a new version and no longer has is unmanaged attribute defined in it because it's now defined in the BCL, what happens? So we need to make sure that we know the existing behavior of the compiler when it sees internal attributes from another assembly, which I don't know for certain what the current behavior is. I need to go look it up. And if so, do we need to generate the appropriate type forwards, or do we need to do something else in order to make sure that that code continues to work when in the presence of new public attributes in the BCL?
So everything you said makes sense. Just to clarify, though, we have violated that split on a few occasions, even recently.
I won't say we're perfect.
Yeah, and I think that's the goal here is either decide what we want to do and then try and be perfect. I think it was earlier in .NET 8 a request came through to add the ref safety attribute. That's not something a developer specifies. We added it, but that kind of goes against the guideline. The required member one, I don't think developers are supposed to write that themselves, but that got added. So.
Is the proposal to make these all public? Sorry if I'm just missing the point.
And they literally just copy pasted from what the compiler has. I assume the attributes would also disappear, like compiler generated and embedded would not be there, and they would all be public. And presumably is unmanaged attribute would have a public constructor as well.
Well, it does, because it doesn't have a non-public constructor.
Well,
it doesn't have an explicit constructor, so it has a default constructor.
Yeah, it depends on what you see here. Because unless you specify, if it's a representation of metadata, then it literally has no constructors right now. If you think of this as code that's being compiled, then the compiler will happily add one for you. I would say, from my point of view, I don't think that putting these in the BCL would slow down the compiler's ability to innovate, because fundamentally, the compiler could still continue doing what it does today, right? When if the type exists in qual, you use it. If it doesn't, you embed it, right? So you can always
we would have to continue doing. We would have to continue doing what we're doing. Like, there's no option to not continue synthesizing.
Yeah, more also moving forward, right, for new attributes, right? It's not just, for the existing ones, for backwards compile, obviously, right? But if you add a new one, for example, you would put immediately into .NET 10, let's say, and then also you would still do what you do today with embedding it if you compile against a target that doesn't have it. So fundamentally, you can still support older versions of the framework, even if we put these types in the BCL.
Sure. What I meant more was in .NET, what was it? .NET or C# 6 when we did nullable, is that right? Or C# 7, C# 8, whatever it was.
C# 8.
Nullable context attribute and nullable attribute went through months of revision with the compiler tweaking what it was outputting along the way. We wouldn't want to put those into the core library until they were done, which would probably mean we wouldn't put them in .NET, whatever came along with C# 8. They'd go into the next version of .NET once it was fully baked.
It depends on viewpoint, right? We could treat it like anything else, right? If we say this feature is experimental or whatever, we would mark these attributes as well.
But then Roslyn has to start being aware of things being in various shapes. How many different versions of it does it have to pay attention to?
Fair enough. Yeah, I guess to your point, it could just be a point in time situation, right? It could just be for one version, it's embedded in the next version, it's put into the framework, right?
Right.
Yep. I think the question becomes we're doing this for bloat, or are we doing this for consistency reasons?
think I will try and channel Eric. I think Eric's concern was bloat.
Yeah, Eric was saying what, a meg or two, or between all the different assemblies that contain different copies of these attributes.
There are other minor usability things like, on SharpLab, you end up seeing everything you do, unless you turn off nullable with a defined pragma, you end up seeing it emitting these attributes because they're part of what Roslyn spits out. So that would go away if they were part of the core library that it was targeting. And similarly, if someone was looking at their own assemblies with ILSpy or something, they wouldn't see them there. So there's some usability benefits.
How does the language specification and these attributes interact? Just calling them out by name and not caring if they're public or what assembly they're in?
I do not believe we care what assembly they're in. That being said, I think Roslyn, the compiler, would want them to be in system private core lib or system.runtime, depending on whether we're talking about the ref assembly or the real assembly.
Because I think some of the things we've done as public before, and I could be wrong, but we've definitely done the ones that users are supposed to type. And I feel like we've also done ones that we thought were important to like reflection, so that you didn't have to go reach it out by name. You could reach it out by a type ref. Of course, that breaks down when you talk about older assemblies because it'll be synthetic anyway. But
I mean, all of these could be relevant to reflection depending on what you're trying to do.
Fair enough.
I mean, if you want to understand the nullable annotations on things you need to know about nullable attribute, nullable context attribute.
And we actually had to go write an API because that was too complicated for people to manually do.
Right.
Because it's really complicated.
Fair enough. So it sounds like the general idea is things are synthetic while they're in development, and then a release or two later say they haven't been touched, so now it's time to freeze them in the BCL to avoid bloat.
That would be one approach if we want to do anything. There's the other approach of just keep on keeping on and maybe even rip some things out that were added in .NET 8 because we sort of went against the grain. For things like scoped ref attribute, like my guess is that that's just a bit, or it's set or not. We don't expect much churn. It could be added the moment it was needed, or late in the release or something, or the next release. There's a spectrum of what we could do. I think we should first need to decide what are we trying to achieve. If we think the size impact is worth it, we can just add and there's not a ton of them. I don't know how many new ones get added every release, but it's probably what, Fred, 2 or 3 in any given C# release we see these come about.
Usually, I actually don't know if we have any of this release.
Or
Trying to think.
trimming.
I'm talking about
trimming
C#
if it's-
language features. I don't think we have anything that is getting an attribute this release.
So for non-Boolean attributes, Fred, presumably once it gets added to the BCL, it now becomes frozen. Like Roslyn can't enhance nullable context attribute after it's public because it was public.
Maybe. I think that is a strong maybe, because we could very easily see, oh hey, we need this new constructor, and the one that we can see doesn't have it, so we'll generate our own. Right, we'll fall back. We could absolutely do that.
So you would generate a synthetic attribute that was a name collision off of the public one.
These are attributes we don't expect anyone to ever use, so I don't think we really care.
Fair enough. Just seems, I guess I don't know if you identify everything by string always, then it would be fine. But if
the compiler does.
If you end up in one zone of like, we type refed it to this one and the other one type refed it to that one, then you'd be in a fun world. Okay, so really my question was, is Rosalind going to be concerned about the inability to evolve things once they go public? And
Not
it sounds like
particularly.
no.
We already do all this stuff by string matching anyway, partially because these attributes come from all sorts of different assemblies, right?
Fair enough. But I don't know that before you've had to deal with the mix and match because you decided to name collide to evolve an attribute. But
we already have to deal with mix and match, absolutely.
all right.
Because we, you reference assembly A and you reference assembly B. Both of them have their own nullable context attribute.
Can you hear me?
Yes, we can hear you, Tanner.
Okay. I was going to say there is one attribute that's going to be added for .NET 8, which is for the ref read only feature that that's being worked on. That needs a new attribute.
I haven't actually looked at the implementation of that one.
Yeah. And then I had a question on if the concern is bloat. The compiler already kind of has to have a well-defined spec for the rough shape of the attribute. Is there any reason why we can't specially recognize the attributes and have the trimmer, linker, etc., centralize them to definitions in corelib, even if they're internal?
You mean in the AOT linker case?
Not even just AOT, but just like in general. If our big concern here is bloat, is there anything that would break the compiler or anything else if the trimmer were made aware of these special internal compiler generated attributes and effectively said, hey, we have these definitions in corelib. We know they're the compiler special attributes. So therefore, replace the definitions in the other assemblies with this one so we can trim it down to the minimal subset and still avoid the bloat without having to expose everything as public.
I don't know how that would really solve the bloat.
Well, it makes sure the attributes are in one assembly, not 15.
Well, but that's only true for trimmed packaged products. That's not true for all the reference assemblies that I download off of GitHub or off of NuGet.
And if the attribute is defined in corelib as internal and the trimmer just rewrites the type def to a type ref, then won't the assembly fail to load because it'll be trying to use an internal non-internals visible to thing in a public way?
We don't actually validate the like at type load time, we don't validate the accessibilities in that way, which is also why reflection is allowed to, touch private fields and stuff like that.
I mean, we could consider doing that, but I think like that seems still quite a bit of work for only solving the problem effectively for packaged products. Yeah, I agree with Fred. Like, I mean, what's appealing to me here is also the simplicity of the end result. Like if you build a .NET 9 library, right, and you open it in ILDASM or Reflector or whatever your favorite decompilation tool is, it is a bit annoying today that, even, with just class 1 in it, there's already like 12 types in it now, right? Because the compiler synthesizes a bunch of attributes. So I think in general, I like the idea that we, clean this up a little bit and, avoid all the code spit into the user's assembly.
Makes sense.
To some extent, like I always kind of cringe when we say like, okay, we do this spit thing and then we use the trimmer to undo it. It's like, it seems like a bit like we deliberately create a mess that we then like clean up later, right? At that point, it's just let's avoid it by construction.
Is C# special here?
In the sense that they're the only ones doing the code spit, you mean?
They're the only ones that we're promoting attributes into corelib for.
F# has attributes, but they don't really define them as IL metadata, they've got this special resource blob they embed into their assemblies that contains all the F# metadata. So it's not that C# is special, it's that F# is more special and doesn't do something that would allow us to do this.
Well, there's also
F# is different in that they have a mix of, for the things that when F# is emitting data that they have inferred about types, like they basically emit things, hey, this is a discriminated union. They basically have one attribute that they have a bit field in for all the different things they've done. Whereas attributes that are more like type declarations, like they have things where you say, like, this is a class, this is a type, things like that. Those are more customer driven. But for the kind of compiler implementation details, they more or less have one attribute that they bit field into.
I guess my thought is, if there was an attribute that they wanted to put into BCL, I think they should be able to. Under system runtime compiler services. It's not C# compiler services, it's compiler services.
I mean, this is one thing that we have talked about before, which is I feel like we kind of try to have our cake and eat it too, which doesn't seem to work in this case, is that we treat some of the things as C# specific, but then basically, you know, things like nullability, which is a C# feature, it becomes effectively an ecosystem thing where we want other parts of the system to reason about those attributes for documentation purposes or for reflection purposes, right? So I think the question becomes, if we design things moving forward, we should be honest with ourselves and say, okay, these things, while they're C# specific, you know, people will ask about these, and so we might as well, you know, design them as, you know, with the intent that eventually they become public APIs, right? They already are kind of like a public API in the sense that, you know, the format is well known and people are parsing it, right? And in that sense, I think C# is special just because it's the lingua franca of .NET and just number of users, right? I know the F# people don't want to hear this, but that's that just happens when you have a 90% customer, right? So then, is there any objection with this shape as proposed? I mean, we can either take it or not take it. We can decide to not take some attributes, but what I'm hearing is you would take them all, right?
Yeah, I mean, we can't change the shapes of any of them at this point.
Right.
So, yeah, I was going to the middle three, I'll use public fields, which we say is a never. We like. Our design guidelines say they should all be get-only properties. Now, if these are defined with this shape in a language spec, there's literally nothing we can do to argue about it, other than does it go in or not. But
yeah, I mean, these are defined this way. This is how every compiler that knows how to read these things knows how to look at them. We can't really change these.
Yeah.
And then assembly location-wise, is it fair to say that in general, when we add new attributes for the compiler, they would always go in core lib?
I think, personally, that's the safest thing we can do. Because these attributes, again, when I was talking earlier about the type forward, but we need to, if we do this, we need to make sure that the compiler doesn't depend on internal types from other assemblies here for these attributes. Otherwise, we might need to start emitting type forwards. And making sure that all assemblies have access to the same set of compiler-based types seems like it would be the safest thing to do.
it also feels like in the limit we end up with every language feature being used in core lib, at which point it would have it as a synthetic or have it as a public.
True.
You guys are going to start using dynamic in core lib? Please look for PR.
Yeah, almost every language feature.
You did not see Jeremy's eye roll. It was great.
So one question, sorry, I'm a little late. I had to deal with some kid stuff this morning. If we did this, like, do we have a clear line in the future of, like, what we would or would not put in core lib? Like, have we defined that? Because, I mean, from the compiler perspective, it's like, okay, you guys, for a while, we put some things in core lib, then we got the message, no, we don't want it in core lib anymore, and go sensitize everything. And it's kind of like, okay, like, we're really kind of, we don't really care what the decision is. It's virtually the same amount of code for us. It's more just, I don't want to waste time filing issues if it's going to be like, no, wrong side of the line, we're not taking this. So do we have a clear line on, like, what we think should be in core lib and what we don't think should be, in the runtime?
We had a clear line. We started violating it by putting more things in than we intended to put in based on that guideline. I think this decision would basically either be reaffirm that line and potentially even remove some of the things that we added earlier in .NET 8, or say the line is now gone and everything goes in core lib. If the compiler would emit an attribute for something into an assembly, that goes in core lib.
Yep, I agreed before. I think the line, like, for the last, I think, probably like 2 years, I felt pretty comfortable with knowing where the line was. But just now, I want to make sure that whatever decision we make, like, I kind of know where that line is again.
In many ways, I think, personally, the answer is they should just all go in once the feature is finished development and somebody would be willing to write it down in an ECMA spec. Because someone like, emo writing APIs of .NET, needing to load the nullable attribute by name and inspect either the call using the metadata annotation or the runtime value of the attribute and then read that back out with reflection, just seems like it's just easier to say, this is the shape, it's here. If you want to talk about it programmatically, go for it.
I assume for something like nullable attribute and nullable context attribute, Roslyn already has code that says, if you wrote this, we're going to error. Like, if you try and put nullable attribute or nullable context attribute on something, it errors.
Yep. It tells you go use the language feature.
And what happens if, for example, you have your own public scoped ref attribute, and then Roslyn decides it actually wants to add a public bool to scope ref attribute? Roslyn ends up emitting its own and just ignoring the one that you defined?
I honestly don't know what happens there.
I'm pretty sure the way the logic works, I'm pretty sure in the compiler, is that our first step is find type by name. And find type by name will always prefer whatever is in your source code over anything else. Is basically source code duplicates core lib. And then once we find that type by name, we then basically look for the members that we expect, the constructors, the fields and what have you. And if those are not present, we error because the type we found didn't meet the specification that we wanted. That's the historical behavior of the compiler. I'm pretty sure Roslyn has that approach.
I see. So that would also mean then that by putting these in core lib, either Roslyn changes its behavior, or if it ever wants to evolve one, it has to create a brand new named attribute rather than reusing the existing one.
Yeah, if we want to start centralizing these attributes, if we're kind of like, okay, going forward, we put everything, in core lib, I'd have to talk with the team, but I suspect we would change our logic to say, for these core attributes, just go to core lib first. The faster lookup anyway.
Right, go to core lib first, but if the one in core lib lacked, for example, the new field that you cared about, you then have to fall back, whereas today it sounds like you error.
If we want to, I'm not sure how often we evolve these attributes. Usually we do it in a compatible fashion, but yeah, we'd have to think through that one.
Yeah, I mean, Fred sounded confident earlier that if corelib didn't have the shape, they could just do another local synthetic inject.
Yeah, I do believe that that should be fine.
Yeah, it's not.
It's the question that I was more interested in was Stephen's. What if it's into public in your own source code? What happens then? And then I don't know, but that's a really weird scenario, and I don't expect to ever encounter it in real life.
Yeah, and I was conflating in your own source versus in corelib because I didn't realize that there was a difference. I'm more interested in there's public API that's the same name that the compiler cares about, but the compiler actually wanted to add something, wanted to evolve it. Today, if it wanted to evolve nullable context attribute, since it's the one injecting it into every assembly, I think it would just evolve it, and it wouldn't really care. But now it can't do that.
It would evolve it, but we would still have to consider what would happen when an older compiler sees that evolution. So we have breaking change concerns within our own attributes as well.
Okay, so does that mean that we haven't ever, and we don't expect to ever, if in C#X we add an attribute, then in C#X+1 we will never consider revising that attribute? It's just easier to do a new one?
I guess I wouldn't say never, but it hasn't happened yet.
Okay.
The compiler doesn't make mistakes, Stephen.
The first rule of compilers, there is no mistake.
Yeah.
It's not a compiler bug. That's the first rule of compilers. I'm actually trying to think back. Like, evolving attributes is scratching some part of my brain. Like, I thought at one time we had to evolve the dynamic attribute just because we found out we could pass information more efficiently. But if we had done that, it would always be one of those, if there's a better API, call the better API. Like, call the constructor that doesn't require an array, just call the constructor that requires, like, one field. But maybe that was, like, a Midori thing. But, yeah, if we evolve attributes, it's extraordinarily rare because I cannot think of a specific case we've done that.
I was in particular thinking of, would we ever, we added a feature that allowed like scope ref to be on parameters, and then we decided actually scope ref also makes sense on properties. So now we need to update the attribute usage or something like that.
Yeah, that's a really good case to bring up. The good news is the CLR doesn't actually validate that you use those correctly, and neither does the compiler sometimes. So we're okay.
Okay.
But that's a really good. I think that's a really good mental one to kind of put into our heads to think about.
So then,
my recollection is we've not ever been doing like EB-never on compiler services. We've said basically the whole namespace is EB-never. There be dragons. Don't look here.
Pretty much.
What did you? Okay. What are you saying? EB-never? I'm not.
Editor browsable.
Oh, EB-never. Gotcha.
I mean, we have not done this for most things in compiler services, right? Because it's like, well, if you look into the namespace, then
that's just me asking the consistency question here of should we be slapping it on? And I believe that our answer is we've said just don't look here.
Yeah. So did I hate this thing here. Did I do anything here did I forget some important point that we want to make? Record for prosperity.
Is this the full list? Have we missed any here?
That's a good question.
I don't know.
Maybe after the meeting, Brad or someone very familiar with Roslyn could go through and figure out all the ones that might possibly omit and make sure we're fully covered.
Yep.
Sure.
Yeah. Is there?
Yeah, and then there's.
Go ahead, Tanner.
I was just going to say there's the proposal for the ref read only attribute that's still being worked on by the compiler. But that doesn't have to be reviewed until we're sure the feature is going to be in.
Yeah, I think moving forward, it would basically mean once we're confident that an attribute is needed, we basically just sort of blanket approval, and we make sure that to whatever extent we care, we're doing API review on so that we don't end up with public read-only byte flag.
Yeah, that was my concern. I was gonna say it'd be nice if the attributes designed by the compiler in the future are consistent with the BCL guidelines.
Fred, can you get a work item filed on Roslyn, because we need to think about how the preference order we look these things up are, and because the moment they start putting these things in core lib, it means the chance that we're going to have compilations which see multiple copies of these attributes is going to increase significantly.
Yep.
And also there's two aspects of one, like thinking through what we do in that scenario. And the other aspect is the way we issue a diagnostic today when there are kind of duplicate attributes in source for us to pick makes it, I can't remember the exact mechanics, but suppressing that warning is very challenging. And we should make sure that that's going to work with this decision.
Okay.
I'm also curious to know for whatever the library is that we have that looks at the nullable attributes and tries to synthesize, reconstitute the annotations from a reflection perspective, we should double check that that actually works when they're not in the same assembly that they're being used. It probably just works, but I wouldn't be surprised if we mess that up. But hopefully that would just cause CI to fail when these got out.
All right.
All right, then I think we can close this one. We have 15 minutes left, so should we do this one here?
Oh, we're only an hour today?
Thursday, we said it didn't fit in 10 minutes, so I don't know that it fits in 15.
Can also go this one here, maybe.
Adam's here just in time.
Who marked this ready for review? Oh, Adam did.
Where's the proposal?
It just splashed up on the screen briefly.
Yeah, you have to remember, Adam, we're not all that smart. We need it in the top box.
There it is.
Wasn't Adam on the call? I think I saw him earlier.
Yeah, you're muted, Adam, if you're trying to talk.
Or he's in that fun state where Teams says he's connected, but his Teams doesn't.
Hello, everyone. Sorry, I was muted and my audio was also disconnected, so I assume you were talking about me right now, Jeremy.
Hi.
Hello.
Yeah, so to give you a very brief introduction, as you know, RandomAccess is an API that allows you to do this exactly the same as FileStream, except of the fact that it does not have an internal state and it has no concept of buffering. And so far we added methods for reading, writing, getting length, setting length, and recently what was noticed was that we are missing a possibility to tell the operating system to flash so far written data to disk to guarantee that everything has been written to disk. Because OS is doing a caching as well, so the fact that write has finished doesn't mean that the data has been already physically written to the disk. And for those who would like to do such an operation, I'm proposing to extend RandomAccess with flash to disk method that accepts safe-i handle and just asks the OS to flash everything to disk.
Is the idea here that like if your process, say, crashes, you want to make sure that the data is persisted?
Yes, exactly.
Okay, got it.
And in case of file stream, we have flash method that gets a Boolean parameter, which determines whether it's flashing to disk or just performing a write of the data from the file stream buffer. So here I'm not proposing a flash method, just flash to disk, because there is no internal buffer here, so there is only flashing to disk.
I assume, Adam, a file stream dot flush with true will just call this method, and B, if you give flush to disk a safe file handle, that's not actually a disk-based file, it's just no ops.
For the first point, yes, this is what FileStream would do. Speaking of other kinds of files like pipes or sockets, so other methods of random access, they typically throw because they are currently not supported because they're all index-based. So to be honest, I haven't thought previously about what should be the behavior. I would rather throw, because if you are using this method with random access, you are most likely reading and writing using the other random access methods, which would throw for non-seekable files.
Don't we ignore those exceptions today in FileStream?
I would need to check. Let me do a quick check. I'm going to open private corlib.
For the class random access, do we really need the to-disk suffix? I think chat has also asked this, but it just seems like flush is unambiguous in this context, and that you mean call the flush.
Yeah, so here I don't have a strong opinion about name. I would prefer to be very explicit. It's flashing to disk, but I'm open to suggestions.
Well, but it's not necessarily. Like if
Right,
if you're a memory-backed file system, there's no disk involved. Like you're assuming a concept that may not be true.
Right, it's telling the driver to flush basically more than anything
Right.
else, and that's driver dependent on what it does. Like I kind of get the idea of flush to disk, and if we wanted to keep this just as an explicit, like we think that this is a 90% case, then we would just document like, look, it actually depends on the underlying system driver, but whatever.
I just think the idea behind this was people that are generally using or used to like the POSIX APIs, and the POSIX flush is just flush. If I've misattributed POSIXness to our design of this class, then that's fine. That's on me.
Just out of curiosity, like when you close a handle, that is guaranteed across all implementations to do an actual honest-to-God flush, right? A safe file handle?
No.
Should we just make closing it do a flush?
That would add non-trivial performance overhead. Yeah, because the operating system is flashing, but it needs some time after you close the handle to perform that. It's not doing that immediately out of the box when handle is being closed.
So what you're really doing here is, if we want it to be very verbose, this would be persist to whatever.
Right. This is flush file buffers on Win32, and this is fsync on Linux.
Okay.
And Steven, in the meantime, I have checked, and I think that we would actually throw for pipes. So basically, we are delegating this to the operating system, at least on Windows. So it depends on Windows what we would do with pipes and sockets for flash file buffers.
I gotta go, but I'm okay with flush to disk. I was going to point out that that's the name of the bool, flush to disk in FileStream.
Right, but FileStream needed it as the disambiguator of flushing, or two kinds of flushing it was doing. And if there's never going to be a second kind of flushing here, then I just wonder if flush is a better name. I don't super care. It felt like a question worth asking.
Yeah, the reason I actually like flush to disk is the same reason that Stefan just gave. Like it's consistent with existing terminology, even though it's a bit strange.
Fair enough.
There was a question about async. I wonder if we should add it just for consistency, just because people like calling async methods, and we'll make it sync.
I don't want
As
to
an
do that.
implementation detail. No, okay.
Thanks, though. In general, we've tried to instill a policy that unless there's some forcing function, we only expose async methods when we can actually implement them asynchronously. That breaks down a little bit with things that are virtual or interface, where we have to then maybe sometimes implement them synchronously or implement them as async over sync. But in general, we've really strived to only expose them asynchronously when we can actually use async IO.
And you don't think that an existing supported operating system or some theoretical future OS might support async flushing?
If some theoretical future one supports it, we can add the API then.
I agree with Stephen on that.
Yeah, the big thing that I'm wondering is, are we going to end up having a lot of code that could have called flush to disk async and probably should have, and now it needs to be recompiled to call that because the only method that was available to them at the time was flush to disk?
I mean, they will have been running with the synchronous one for a decade or years or whatever. They can stand to recompile one more time to get the right thing in their code. I'd rather than do that than think that something's happening asynchronously when in practice it's just blocking the current thread.
Sounds good. No, thanks for humoring the question.
No, it's a good question. I mean, we get it. We've gotten it a couple times for flush TS. The bigger one we get is for file open, where none of our operating systems that we target support any notion of asynchronously opening a file.
Except for WebAssembly, which was considering it and forcing it to be async and blocking you doing it synchronously. But yeah. And by blocking in that context, I mean failing, not blocking the thread. But yes.
Sounds good.
Cool. Ship it.
Thank you very much.
Is this an easy one, at least, or is it also hard, Tanner?
It's easy. The premise here is that we exposed UTF-8 parser, and it has the special behavior that it will terminate on the first invalid character rather than failing. So it just treats it as end of string effectively. So the proposal is that we expose a NumberStyles option, allowing users to opt into this behavior, and then we expose 3 virtual methods on try-parse that handle this.
Which type should they go?
And that's supposed to be on a iNumber base.
iNumber base, I see.
Yep. There was a few different suggestions for names. The one, and I listed some of them below, but the one I ended up liking best was the one Steven suggested of allow trailing invalid characters. And what exactly an invalid character is will be dependent on the implementer.
Yeah, that was going to be my question. So if the parse method would have allowed it, then it's considered a valid character.
Right.
Okay.
Well, like parse will allow /0, right? But
yeah,
we would want to treat that as invalid in this case. Or
yeah,
no?
that was something Levi brought up, was that there's a couple edge case quirk behaviors where for example, null is allowed in a valid string for provided it's the final character or final sequence of characters. We would likely we would not include those nulls as part of, and we have the option of either including or not including those nulls in the out characters parsed parameter. UTF-8 currently does not include them, and so we'd probably want to consider that the same. The user still gets the valid string. It just makes a difference on whether or not it's included in the character count.
Sure. There is you would need to figure out what the user experience is when they call try parse, and then it returns a value saying, I have not finished consuming everything. Like, what is the user expected to do at that point?
Right. The general intent here is to match what UTF-8 does.
You mean the UTF-8 parser class?
What UTF-8 parser class does.
Sure. Because what you don't necessarily want to end up with is a situation where somebody has a functioning application that calls int.parse. They go and change it to call this method in a loop, and then their application has different observable runtime behavior. Or maybe you do want that, I don't know. It should be explicitly listed if that is a goal.
Yeah. And in particular, this is a little bit different because it returns the number of characters processed. So with the previous one, they already would have had to have been manually determining that character count and splitting or assuming the entire thing is valid.
Right. This seems reasonable then. The string-based overload is kind of interesting because if the intent is that somebody, say, slices the string and then keeps, or substrings it and then keeps going, doesn't that imply that they would be using the char-based or the span-based overloads? Or is the string one still just for simplicity?
It's for consistency and simplicity because they might be starting with a string and then they might end up slicing after.
Could we potentially take, if we take a string, should we take an offset and a length?
We could. We don't have any other APIs that take it today, though. So I would think we'd either take it like this with the string and then later consider whether or not offset length is worth exposing and whether it needs to be broadly across all, or say for now just expose the span ones.
What I might recommend here then is, oh, actually they're all virtual. None of them are abstract, of course, because it's, wait, would there be a default implementation for this? There would have to be.
Yeah, the default implementation defers to the regular try parse method and assumes the entire thing is consumed.
Okay,
because that's the only implementation we could do.
Right.
Yeah, then this all makes sense.
So we happy with that shape then?
I do have one more question. So what would the default implementation do for allow trailing invalid characters? If you've set it?
Well, there's two options. We can either treat it as invalid and throw, which is probably undesirable, or we could have it defer to the regular parse implementation, masking off that flag bit. And then treat it as the entire sequence was consumed.
Or there's the third option, which is just delegate to parse and assume that that implementation is going to throw if it sees a number style it doesn't understand.
So the
right, that was the throwing case.
So I thought by throwing, I thought you meant try parse itself would throw.
Oh yeah.
Yeah. So you would pass it down to the normal implementation. The normal implementation would say, I see this bit set, I don't know what this bit means, and then kick it back out to you. Okay.
I think any of those three options is viable. I'd prefer the second or third option. I don't think try parse itself should, assuming I understood what the first option was, I don't think try parse itself should just see that style and throw, because that would prevent, that would limit what an implementation could do. But if we want to mask it off, or if we want to just delegate, I'd prefer if we just delegated. With the risk of just Can
you summarize the three options again, so we're on the same page what they are referring to?
Try parse sees number styles dot allow trailing invalid character set and throws an exception explicitly. This is in the default implementation. That's option one. Option two is when try parse delegates to parse, it masks off allow trailing invalid character, so it calls parse without that option set. And option three is try parse simply delegates to parse and assumes that parse will either handle allow trailing invalid characters or will throw an exception if it doesn't know what it is.
So the reason I'm asking is because the parse method on int right now treats a trailing null as valid, but you're suggesting that this method would be special cased to say that null is considered an invalid character and is not consumed.
In 32.parse today will also throw an exception if you give it a number styles it doesn't understand.
Right. But that's if I think one of your scenarios was strip it off and then call the parse method.
That was option two.
Yeah. I think we're okay. I can't imagine this is like fatal to the implementation, but it's just something that we would need to be really careful about because we're potentially changing behavior in that case.
Right. We'll want explicit tests covering the known edge cases for like trailing null characters and making sure it's consistent between the default implementation and the explicitly overridden behavior.
Right, because you're implied in what you were saying for option 3 was that the parse method would also understand this flag and do something with it.
Mm-hmm.
Just ignore them, I guess.
Presumably not.
Yeah, the only real. Yeah, the only really quirky behavior is if we delegate to try parse and it understood the behavior, and the default implementation assumed the entire string was consumed, then you get in the weird edge case of the underlying implementation did not treat those as consumed, but the default implementation would, and so we just have to make sure that's accurately handled.
Yeah. It just seems like maybe we just have some edge cases we need to test for, but it still seems totally viable.
So which of the two options are we then leaning to? Is that option 3 then, effectively?
Yeah, I think option 3, and I had intended, when I had phrased it would throw an exception, I had intended that to be, it defers to the underlying implementation, which is what would throw. So my option 1 was really the same as Steven's option 3. I just worded it badly.
Got it. Sorry.
Yeah.
So the default implementation is basically call parse set chars consume equal to s.length and return true.
Right.
Because parse is gonna not handle how are we gonna get chars consumed? Parse doesn't report that.
Chars consumed equals
We-
s.length.
Yeah, everything.
Yeah.
But if parse supports allow trailing invalid characters, I guess I don't know what try-parse is supposed to do for consumed if allow trailing is set to true. Did it consume them or not?
It consumed them if the implementation was so. We're introducing a new value for the flag, which means
Sure.
that your parse method and your implementation of this method would both be modified at the same time. So I think that's okay.
But I guess try parse would actually be a try catch default, where if it throws format exception, then it returns false.
No, because that would be an argument exception. You've given it something it literally doesn't know how to do.
No, that's if it would be an argument exception if it doesn't understand the number style. But if you gave it a string it couldn't parse, then I think it throws a format exception.
Oh, yes, correct.
So you would. Yeah, I mean, if we're saying that the default, if parse handles allow trailing, that if you didn't customize your try parse to not report them, then they were consumed. But that feels like it's going to just make a very inconsistent. Like, makes me wonder if we should cut that parameter. But it'll be fine. I'll get over it.
I think really
just
the only
document it.
weird case is, I think the only really weird case is if someone decided to implement the flag without overriding the try parse method, then they could end up with inconsistent state.
Mhm.
I think it's explainable though.
But as long as they're actually implementing and overriding the methods to ensure that they're consistent, then there shouldn't be a problem.
But even in that case where they don't override the new try parse, they've overridden the old try parse, implemented allow trailing invalid characters, but they're basically saying at that point is I've implemented allow trailing invalid characters by stating that they're part of the parsed value.
Mhm.
And so the character count you get back is the full thing.
Yeah, it means that it's hard to write like a CSV style parser, because it's going to end up reading the first value and then saying, I'm done, I've consumed absolutely everything.
Yep.
But again, because the flag and try parse overloads are being introduced in the same release, I don't think we're ever going to naturally get into an inconsistent state.
Yeah, and in practice, the number of people that implement this interface is very small.
Yeah,
Right.
I mean, if we had the attribute of like, if you're young enough, or yeah, if you're a young enough TFM that you can see that this exists, I don't care, it's virtual, you have to write it.
Yes.
I would happily put that on this.
Yeah, and we could even document like these are the expectations of people, implementing this type, writing parse methods. This is what the flag means, and so on. Like that seems like something that can just be solved through docs. And if we really needed a code analyzer, but that seems like a really heavy hammer for this, considering it's theoretical.
And the real intent of this is just, let's make sure that the custom parsing behavior that's currently UTF-8 only that people want to be able to use is available for UTF-8, UTF-16 via the actual interfaces, so anyone can rely on it safely no matter what their scenario. Just make the world consistent moving forward.
Yeah, no, yeah, it's just about the torn state that it can introduce, and if we don't think it's a problem, then moving on. Where Emo's only like 15 minutes late to his other meeting.
I think the meeting starts 10 after, so I think I'm technically 1 minute late now. But
Perfect.
all right, so then I call it done, and thanks everyone, and I see you on
Thank you.
Thursday.